Consider the two words parallel and lines. How many arrangements of the letters of the word lines have the vowels grouped together? So we're looking at the number, how many, and we have two vowels. If I just wanted to know how many ways there is to do lines, regardless, remember what it would have been, let's just use another color. It would have been 5 faculty because 5 factorial, because 5 factorial, there's 1, 2, 3, 4, 5 different things. But what happens now is we have to group two of them together. So the vowels needs to be IE, and then we still have L, N, and S. So I can say the number of vowels will equal, and I take this group, so this group I'm going to take as one group. So I have 1, 2, 3, 4 elements. So the number of arrangements with 4 groups is 4 factorial. Okay, but remember that the I and E can also swap places. For every one of these cases, I and E can swap. And that's why we're going to multiply then with 2 factorial. And the 2 factorial is for the groups. So this factorial is for this groups. And 4 factorial is 1, 2, 3, 4. That will give us, now, calculator, no problem. If you don't have a calculator, you will actually have to go and calculate it. That is 4 times 3 times 2 times 1 times 2. 4 times 3 is 12. 12 times 2 is 24. Times 2 is 48. So there's 48 different. So out of this 5 factorial, and 5 factorial we know now is 5 factorial, which you can calculate with a calculator, is 120. So it's 48 out of 120 that the vowels will be together. Let's have a look at B. How many arrangements, again it's a number, how many arrangements of the letters of the word lines have their vowels separated? So the number of vowels separated. Right, if I want to separate the vowels, it's a little bit harder because you can't group them together and you can't group them apart either. So what we'll have to do is we'll have to say that the total number of vowels separated will be the total number of vowels, vowels, take away the number of vowels together. The number of vowels, I should have said at the top together or grouped. The number of vowels, take away the number of vowels grouped. That is where they will be apart. So the number of vowels, the total number of, it's not the total number of vowels, people, sorry about that. It's the total number of the sample space. The total number of arrangements. Total number of arrangements, take away the vowels of the group. Which means, that's what I say, if I just look at the values, it would be 5 factorial, take away 48, which is 4 factorial, 2 factorial. Okay, so it's 4 factorial, 2 factorial. Or it is 48, and the 48 we get from the previous step. Now 5 factorial, 5 times 4 times 3 times 2 times 1, that will give us 120. And 120 take away 48 gives us an answer of 72. C. They ask us how many arrangements. So we're looking for a number. The number of arrangements of the letters of the word parallel are possible. So the number of arrangements, this is what we're looking for. The number of arrangements. We need to remember that if I have some of those individual individual objects within these things are the same. So A is the same, L is the same. I have to use my formula, and the formula that we're going to use is the following. We're going to say it's n factorial, how many elements there are, divide by p, which is 1, whatever is repeating itself. Okay, so in altogether there is 1, 2, 3, 4, 5, 6, 7, 8. So we're going to say this is 8 factorial. Divide by whatever repeats. Now the repeating is A, so A repeat twice, so it's 2 factorial. And L repeats itself 3 times, so that's 3 factorial. You are supposed to simplify that to a number. To do this on your calculator, you can do it on your calculator, but remember what's going to happen here. I'm going to have 8 times 7 times 6 times 5 times 4 times 3 factorial, which means times 2, but I'm only going to stop at the highest one because this 2 factorial, 3 factorial underneath the line, this factorial and that factorial will cancel, so I won't take that any further. 2 factorial is 1 times 2. 2 goes itself once and 4 twice, and that gives me a total answer of 8 times 7 times 6 times 5 times 2, give me an answer of 3,360. So that's the number of arrangements that I have. Why? Because some of the arrangements, if I just said, looking back at the top, 1, 2, 3, 4, 5, 6, 7, 8, if I just said 8 factorial, many of them will look exactly the same because the L's can repeat themselves and the A's can repeat themselves. And when they take the same space, they look at exactly the same way. And let's look at the last one. I'm going to do it here at the top so we have a place to look at. And this one is a little bit hard. I'm going to do it another color so it's easier to follow. So I'm going to say D. And what I'm going to do with D is they say, what is the probability? Now, we need the probability, right, that we have the A's together. Now, the probability of having A's together is the number of where the A's are together divided by the number of arrangements or my sample space. Okay, so let's go and look at what is the number of arrangements. For A to be together, I can put A together, and I'm going to do it over here. I'm going to say I have A and A together in a group. Then I have a P, R, L, L, E, L. Okay, so I have 1, 2, 3, 4, 5, 6, 7. So it's 7 factorial. Divide by 2 factorial. Oh, this is just one group. Remember, this is one group. So it's 7 factorial, and there's 3 L's that repeats itself, so it's divided by 3 factorial. So that 3 factorial, I'm going to just use another color. 3 factorial here comes from the fact that they are there. So that's the number of ways that I can have A together. Now, I don't divide by another A like we've done previously, because these A's are grouped together and I see them as a unit. So they are already together. I'm not going to be concerned about them. It's 7 factorial, 1, 2, 1, 2, 3, 4, 5, 6, 7 different factorials, and they sorry, not 7 factorials, 7 different positions they can be in, and therefore it's 7 factorial. Divide by 3 because 3 of them are repeating themselves. So that is NA, so I have this value at the top. Now I still have to find the overall, and the overall we've already calculated, and I'm not going to go back and use 3,360, otherwise I have to do a lot of maths again. Okay, so I'm just going to say that the number of everything together is the number of arrangements that we have over there. So the number of arrangements that we have over here is 8 faculty not faculty, 8 factorial divided by 2 factorial, 3 factorial. Okay, so if I do now my maths, I'm going to say probability of having my two A's together is this divided by this, according to what I have in my example, or in my values. So it's going to be 7 factorial over 3 factorial divided by 8 factorial over 2 factorial, 3 factorial. That's the same as 7 factorial over 3 factorial multiplied by 2 factorial over 3 factorial divided by 8 factorial. They cancel because they're exactly the same. 8 I can write, so I'm just going to write this on the side. I'm going to say that 8 factorial equals 8 times 7 times 6, and that's the same as 8 times 7 factorial, which means that 7 factorial cancel with 7 of those, and all that's left is the number 8. 2 factorial is 1 times 2. 2 go himself once and 8 4. So I have an answer of 1 in 4. So there's a quarter chance that if I'd randomly chosen the word parallel, the letters AA are together 25% of the time.